In this lab, let's look at plotting box plot and violin plot. Let's look at the data frame for the household survey in Australia. So the data frame household survey has columns HHID, HH structure, dwell type, on dwell, household INC group, household size, years lived, total bikes used, total VEH, adults, age 5 to 18, tertiary education, secondary education, primary education, full-time, part-time, casual, total work, total trips. Let fig equal px, where px represent the library pyplot.express. So px dot box of df, which is the data frame, comma x equal on dwell, comma y equal is lived, comma color equal dwell type. Fig.show, open and close bracket. So the x-axis represents on dwell and the y-axis represent years lived, and the color is given by the dwell type, and it's a box plot. So px.box gives interactive box plot. Interactive when we move the cursor over the boxes, it gives us the information, the box information. So for the on dwell being purchased, years lived range from minimum 0 to maximum 40, and the median is 5, and the first quartile is 2.25, the third quartile is 13, and the upper fence is 29, and the box with the very long tail, the range is from 0 to 60. The upper fence is also 60, and the lower fence is also 0. Median is 17, quartile 1 is 7, quartile 3 is 30.75. And that's for the ound house. Now, by looking at this, we can see that the maximum is for the ound house, and it's for the separate house. So the separate house, which is ound, has the maximum years lived is 60, and the lowest years lived is 0, and yeah, that's almost 4. But the green one over here for the house type being purchased, which is flat or apartment, the minimum years lived is 2, and the maximum is 5. So for the green one, the maximum so far lived is for the owned flat or apartment, and that's 31 years, and the minimum is 1 year. And for the rented one, the minimum is 0 year, and the maximum is 25 years. For the terrace or townhouse, which is the red one, the is very less people live there. The minimum years lived is 0, is 1 for being purchased, and the maximum is 4. The highest is lived by the owned households index for the terrace or townhouse, and the maximum is 25 years lived. Let's add one more parameter. Let's add notched equal true. So notched equal true gives us a notch at the end of the box. So for example, if I put my cursor on this one, then this is for the separate house, and this is occupied but rent free, and the maximum number of years lived is 44, and the minimum is 0. So notched is just the designing tool of the boxes. Then we look at the sun-based chart. You would be already aware of charts such as pie chart, which are suitable to check composition within the data. With Plotly, we can go a step further and build sun-based charts. Introducing sun-based chart, using which we could create an interactive pie chart wherein the parents of the components can also be mapped. Sun-based chart is especially helpful when we have multiple children columns or categories, and even their corresponding parent categories. You can find more information on sun-based chart at https://plotly.com/python/sun-based-charts/. So this is where you can get more information on the sun-based chart. Let's look at the car's data frame. The car's data frame has object ID, has the index, and the columns are the basic color, body type, CC rating, first New Zealand registration year, first New Zealand registration month, gross vehicle mass, import status, industry class, make, model, and so on. Let's subset the rows which has name, which has unknown values. So we pass the command the data frame square bracket, the data frame dot is na, open and close bracket, dot any, in the bracket we'll put x is equal 1. X is equal 1 is referring to the columns. So there are no data rows having name values. Let fig equal px dot sunbased of cast data frame, comma, the path is motive power, comma, body type. So first it will be motive power, and then the body type will follow. Values equal power rating. So the values we're using is the power rating. Fig.show, open and close bracket, will plot the figure. So we have motive power petrol and diesel. Petrol has body type saloon, hatchback, station wagon, motorcycle, utility, light van, and this is convertible. And we can see that saloon has higher, there are many there are higher power ratings. So a lot of vehicles have power rating which belongs to saloon. There are many vehicles. Highest number of vehicles are having the body type saloon. And for the petrol vehicles, so the petrol vehicles are higher compared to the diesel vehicles. And the diesel, among the diesel vehicles, the utility body type is the highest in number. And among the petrol vehicles, saloon is the highest number of body types. And the power rating is 17.316. Utility, the power rating is 4.165. Let's look at the data frame dot power rating dot value underscore counts open and close bracket. So we see a lot of power ratings are 0. So there are a lot of missing power rating, and there are 615 of them vehicles having 0 power rating, which are the missing values. Let's subset from the car's data frame motive power, comma, body type, comma, power rating, and we do dot value underscore counts open and close bracket. So we have motive power petrol having body type station wagon, saloon, hatchback, and the power rating is all 0. And then we have the counts. Then we have, let's have a look, petrol, then we have station wagon, and the power rating, so we have body type station wagon for petrol, and the power rating is 0. Okay, so let's have a look. So petrol, station wagon, petrol power rating is 40.114, and then station wagon, we subset the station wagon, the power rating is 7675, and for petrol 40,000, okay, 7675, and we have 0. The petrol motive power body type station wagon, power rating is 0, and that's 137. And for saloon, power rating is 0, and there are 135 of them. And for hatchback, 0, we have 90 of them. The motive power 0, body type is domestic trailer, and the power rating is 0. Motive power is petrol, and we have utility. So there are continuous signs over here. So these are the data, and if we want to know what is in the continuous represented by these continuous dots, we we just perform little bit more commands. Diesel has utility, power rating is 147, and there is 1. Let's have a look at diesel. Diesel utility And yeah, so petrol, utility, power rating is 235, and there is one of them. Uh, okay. So where the values are 0 is not given. DF cars dot motive power dot value counts. So petrol is 740 and the diesel is 164 and 0 is 96. Let's do another plot. Let fig equal px dot sunburst of df cars 2. So df cars 2 data frame was creating by excluding the motive power 0. Path equal motive power and body type. Values equal power rating. Fig dot show open and close bracket. So we get this. It looks very similar to this graph here. So this plot over here automatically has discarded all those power rating that all those motive power that was 0. And so the two graphs are very similar. Let temp equal pandas dot data frame bracket the cast 2 data frame double square bracket motive power body type power rating, and we get this. So this data frame excludes all those motive power that has value of 0. And this data frame, we look at the power rating and value counts of it. We see that 0 is 519 values, and that's highest. Let temp cars equal temp, and we subset the temp power rating not equal to 0. Let's look at the temp cars. So this includes only the motive power equal to not power rating not equal to 0, and there are 385 data rows. Let's plot this. Let fig equal px dot sunbest of temp cars, path equal motive power, body type, values equal power rating, color equal power rating. So we get this. So motorcycle, we have motorcycle in here. So did we had motorcycle before? Yes, we did. Okay, so what is the difference? So the highest power rating is for motorcycle, and that is shown by the yellow color. And the power rating is 2227 and is for the petrol motorcycle. And for the petrol vehicles, the light vein seems to be lowest for the power rating, and which is 1010. Even convertible is much smaller at 885. Even minibus is smaller. And for diesel vehicles, utility is the highest, and that's with the power rating 4165. The lowest is with seems to be with heavy van. The power rating is 148. Let's add one more parameter. Let's add color underscore continuous underscore scale equal ice. Fig.show open and close bracket. So the color is changed to ice. So the color mapping used is ice, and motorcycle is again the power rating is the highest, and the lowest is around 100, and that's utility type diesel vehicles and um, hatchback type petrol vehicles. The blue ones are around 150 to 200, and that's for saloon, station wagon, utility, convertible for petrol vehicles, and station wagon, saloon for diesel. So use a sun-based plot to show a relationship in the household travel survey of your choice. We will do that in the next lab.